And here, one of the last slides I'll maybe show you just to illustrate this point again, is here's some of the genes that control vitamin D. And there are about 2,000 of those genes reported in the literature. And you can see some of them here. They're all along this pathway. Here are these enzymes, these CYP enzymes that we were talking about. And what happens, and there's the vitamin D receptor, and we've talked about SNPs in all of these. But what happens is this becomes activated, this vitamin D becomes activated. Transcription factors sit down on this uncoiled DNA, so transcription factors, and what do? They induce activation of many IR, immune response genes. For example, those encoding cytokines, chemokines, defensins, and others. So here you see the immune system. You can see it's pretty complicated. There's all kinds of cells, and there's about 5,000 genes that control the immune system, and you can see some of those. But this red arrow shows the influence that the vitamin D system has on the immune system. Complicated, right? 2,000 genes interacting with another 5,000 genes in a finely tuned orchestra. So we need to learn more about that, but there's no doubt in my mind that this is exactly what's happening. And this slide I did steal from Dr. Hullock, and it came out of an older publication, 1987. But he shows something that I think people need to understand about cells of the immune system, and that's that they activate vitamin D differently than bones, for example. So this is an activated macrophage, which is depicted here. And what it's showing is that this macrophage, without the help of the kidney and some of those enzymes, can take 25-hydroxy D3, and they all on their little lonesome can convert it to 125. So they're absolutely bypassing some of the system. Oh, why would that be? That's because when they need vitamin D, they need it instantaneously. They can't be waiting for the kidney to do whatever it's going to do. And the kidney has sort of another job. So these cells of the immune system have their own bypass so that they can grab vitamin D. Well, why on earth would they do that? It's because the previous slide I showed you shows that vitamin D is essential for optimizing immune function. So hopefully that kind of tells like a little story. Oh, and then we're back to that. So, that's just some of the little bits of critical information that I think might help